So next up, we have Wes Bos talking to us about getting better at JavaScript with plain JavaScript.
All right. Hey, folks. Last talk of the day. I'm supposed to say something about, like, the only thing that stands between me and you and beer is just my talk, so I won't keep you long, right? I might keep you long. All right. So, are my slides up? I can't see them. No. Somebody turn them on. Beautiful. So before we get into anything, dad jokes, I appreciate them. I have a GitHub repo full of currently 102 dad jokes. So if you want more, like I could do an hour here of just dad jokes if we wanted to. They're pretty funny, I think. I didn't make them all up, so if you're offended by some of them, I'm sorry. But most of them are pretty tame. All right, let's jump. Sorry? www.github.com/wesbos/dad-jokes. Or just search dad jokes. I'm sure it's #1 on GitHub. All right, my name is Wes. I'm coming from Canada, which is why I say, woo, any Canadians in the house? Yes. All the Jamstack people are Canadian for some reason. I make web development courses. Anyone ever taken one of my courses before? Awesome. Anyone ever listen to my podcast called Syntax? Yes. Beautiful. It's at Syntax FM. These slides are going to be available after the talk. I'm at Wes Bos on Twitter. I'm going to go through this quickly because I have so much cool stuff I want to show you today. So I'm calling this talk Getting Better at JavaScript. And it's just a mixed bags of tips and techniques and just things that I build websites every single day, and these are the things in JavaScript that I find extremely helpful, regardless of if you're building in React or vanilla JavaScript or whatever you're doing. We all have JavaScript as the core base for building our websites, and these are things I think are going to make you a better JavaScript developer. So first one, my lunch got eaten on that last talk, which is Intersection Observer. I'm going to talk to you about it anyway. It shows you when is an element on the screen, partially on the screen, all the way off the screen. So here's my stupid little, I don't know how to make graphics. So I made this to sort of visualize. You get the point, right? When the puppy's on the screen, we want to do something with it. So with Intersection Observer, we can be alerted when an element is fully or partially scrolled into view. So some uses for that: if you want to animate an element in on scroll, you want to play a video when somebody scrolls into it, you want to lazy load images like we just saw on the last talk, or just data reporting, like is this ad actually getting viewed by people, or are people scrolling that much further? You can use it with sticky headers as well. So here's a stupid example that it came up with where it has really obnoxious pigs that zoom in and out as you scroll in. And all I'm doing there is adding and removing a class. Same thing with, you can sort of mimic the sticky header effect with something like this. You can tell when something isn't on top, scrolled into view. So when I was actually building this talk, talking about it, I'm like, oh, this is really cool, Intersection Observer. I wonder where I could use that in my own application. And then I was going through this, and I was like, you know what? My machine is just firing up because I have all these video demos in my slide deck, and I need to somehow pause them when they're not on screen. And I was like, oh, perfect. I could just loop over every single video and say, when a video is on the screen, then play it. And when a video is off the screen, then pause it, right? Very simple. I didn't need to hook into my slide deck API for on-click or anything crazy like that. I just say, if it's showing, play it. So here's how it works. First thing you do is you set up some options. You give it a scrolling div, or you give it the body by default. You can give it some margin if you have some offsets, and then you tell it what the threshold is. So in this case, I want to be alerted when the element is 0 off screen, half on screen, and totally on screen. Then you create a new empty intersection observer. You pass it a callback. And what that will do is it's going to give you an array of all of the elements that you are currently watching. So in my video example, an array of all the current videos in there. Then you can go ahead and loop over each of them, and you're going to get two important properties: entry.isIntersecting, true or false, and entry.intersection ratio. That's going to tell you exactly how much that element is currently scrolled into the viewport. From there on out, you can add or remove classes. You can fire network requests to download images. You can download code bundles for links that are contained inside the view. The sky's the limit at that point. Then you go ahead and loop over all the elements that you wish to observe. So it might be a video tag, it might be link tags, it might be just a div that you care about that has maybe some sort of ad inside of it, and you observe on it. When that does trigger, when the observer triggers, you get a whole bunch of helpful information. Most notably, you get the intersection ratio, but you also get information about like how big is this element, the x, the y, the width, the height, which is very handy for measuring things. Sort of in the same thread, we now have Resize Observer, which is per element resize events. Right now, like before this, the only resize event that we had was window. So it's pretty simple. You just grab onto an element, you wait for it to be resized, and when it's resized, the browser will let you know everything about it, the x, the y, the width, and the height. And it turns out this is really handy for measuring elements if you need to do things like animating height auto or whatnot. There's some really cool hooks in React that just give you like a live variable of the width and the height of the actual element. It works like this, very similar. You create a new Resize Observer, you get a callback with all of the entries, and then inside of that entry, you get information about how big is the actual element. This is really like a gateway drug to element queries. Element queries is this thing that we've wanted in CSS for a long time where I don't want to size things based on the viewport. I want to size things based on how big they are, where they are in my application, right? Your component might be sized differently depending on what sort of container it's inside. So this is just very simple. Look at the first couple lines of code here. I just say if the width is greater than 400, then make the size large. Otherwise, make it medium. Otherwise, make it small. And then at that point, I can simply just add a class of small, medium, or large to my element. And that gives me something like this, where I'm not resizing the browser here. I'm just resizing the video, which in turn resizes the list of videos on the side. And depending on how big that list of videos is, then I want to add or remove classes so I can style it a little bit differently. Ideally, we wouldn't need any JavaScript for this, but for now, it's actually not a bad option, especially if you're using something like React, where you're running JavaScript anyway, and you can easily add and remove those classes. So next up is DOM element methods. So this is just like, as we call, vanilla JavaScript. But these are some that I find particularly helpful, even if you are running in React or Angular or one of these frameworks. So the first one is .closest. So anytime you have an element, there's a method on it that is .closest. This is going to find the closest ancestor, the closest parent, grandparent, great-grandparent that matches the past selector. So let's look at these cards. I got a div with 2 cards inside of it, and then I've got some buttons in each of those cards. When I click the button, I want to remove the card, right? And you can probably think to your back to your old jQuery days where you'd like go up 3 levels, over 2 levels, down 3 levels. With closest, what you can do is you can just say like, okay, someone clicked the delete button. Now, let me just start searching up the DOM tree for something that matches this selector, in our case, .card, and then you can go ahead and remove it out of there. It's really cool because it takes like complex CSS selectors, so pretty much anything you can think of in CSS will also work inside of here. So this will return the closest ancestor that is a div and has a parent article. So you could say like, yeah, give me the div, but only the one that has a direct parent that is an article. So you might not know necessarily how many divs are nested inside of this element, but you want to find the one that's directly underneath the opening article tag. You can chain them with multiple knots, which is pretty cool. And this is extremely helpful for click outside. Like, how many of you have written click outside like 80 times in your career, right? Sucks. It's always like, oh, that's easy, right? And they're like, oh no, there's this little weird case and events bubble, and there's all this like kind of tricky stuff with it. Well, Closest actually makes it really simple, where you take the document or the window and you listen for a click at the very high level, and then what you do is you say, in our case, .modal inner is the inside, right? That's the white part. So what we say is if it's not the modal inner, so like if it can't find the element modal inner, meaning that you never clicked anything inside of the modal inner or the modal inner itself, then you're outside. Otherwise, you're inside. And then you can just go ahead and close your modal box or anything you want like that. So that takes that like sort of hard thing, which was click outside, and makes it just a simple one-liner. Dot matches. Does an element match the selector? So here, when you click on a button, and you often need to check if that button has specific attributes. In our case, I could say, like, if the current target has a class of available, and it also has a data set, which in turn has a property called price, or you could just say, like, it doesn't match the selector that I have available and has a data-price available to it. And maybe in that case, you only wanted people to click a button when it had a class of available and a price set. I find this extremely helpful for what's called event delegation. So let's picture you have an unordered list with a bunch of list items inside of that. And that unordered list you've created, and it's in the DOM, but those list items are added and removed via your JavaScript code. So the downside to that is that you would have to like add and remove event listeners on each of those list items every single time you add or remove one. But in this case, what you can do is you can delegate the clicking of those list items to the parent that you know will always be there. And then you say, when somebody clicks the UL, check if they actually clicked a list item inside of it, or check if they actually clicked a button inside of it. So if the target of the click was actually a button and not just on the regular unordered list, then go ahead and do something. And in my case, go ahead and delete item. In this case, I only have one event listener and not, I don't know, 9 or 10 based on how many items are in that list. .contains. This is pretty simple. You have an element, and you want to check if another element is inside of it. If you have reference to that element, you can just say, if it's inside of it, it's .contains. If you want to pass it a selector, like we were doing in the previous examples, you can just use regular old query selector, or if you want just a Boolean, you can use the double bang operator to coerce it into a Boolean. Next up is Bling.js. This is actually not new. This is probably, I don't know, maybe 4 years old. Anyone ever used Bling.js before? No. So I think that this is the best 11 lines of code. If you're writing any, this is not necessarily for a framework, but if you're whipping up a quick vanilla JavaScript website, Bling.js is going to go a long way. So these are the 11 lines that we have here. And what we're going to do is we're going to break them down into understanding what each of those do. So the first part is this one, window.dollar and window.dollar. This is obviously trying to mimic sort of a jQuery API. Instead of using the extremely hard to type and easy to misspell document.querySelectorAll, you can use dollar and $$ in order to sort of shortcut those to document.querySelector. You may even know that in Chrome DevTools, those are already shortcutted for you, which is pretty cool. You don't have to type document.querySelectorAll. So if you want to go ahead and select one element, use the single $. If you want to select multiple elements, use the double $. Some people do it all in one, sort of like the magic of jQuery, but I prefer not to stray too far from the light of vanilla JavaScript and keep it as standard as I can. Next one is you take any node and you modify the prototype to add a method called on, and you also add a method called on the window. And all that does is it just makes a new method, which in turn will add an event listener to the actual element itself. So instead of doing document.querySelector card.addEventListener click, handle click, you can simply select the element, check for, say on, click, and then you can handle the click. Which is a nice, clean API. This one is pretty cool. So a node list does not have all of the methods that an array does. So nodeless has like dot for each, and I think that's about it. There's a couple other methods on there, but it doesn't have like map and reduce and all of the methods that you're used to on a proper array. So you can just quickly modify the prototype, and you have access to doing things like mapping over multiple found elements. There's another example that we have there. All right, next section that we have here is called data massaging. And these are just the tips and tricks. Or you get an array or an object of data, you need to modify it somehow, and then you need to send that data off or display it to the user or something. Like, that's a lot of what we do is trying to force data into the form factor that we're working with. So the first one is a method, a static method on array called array.from, and it will turn what's called an iterable into an array. And the very simplest iterable that you have is just an object with a length property. And I very often find myself wanting to, like, I need an array with 10 slots inside of it. I need an array with 10 items in it, and I need to fill those items with something, right? So here you can do is you can say array from, you give it a length of 3, and then the second argument to array from is a map function that works exactly like a normal .map function on an array. So whatever is returned from your map function will be populated into the array. So where is that useful? Well, I find myself needing to make an array full of like day 1, day 2, day 3, day 4, etc. So instead of just manually typing out that array, I'll quickly just generate it with something like that. Also, one really good use case for this is, like, how many of you have ever done a quick Google of array of weekday names or array of months, right? And like, we all do that, and we're like, why is there no array of month names in the browser? And it turns out you can generate it. You probably want to like memoize this or something like that because it doesn't make sense to generate it on every load. But what you can do is you take array from, give yourself a length of 12, because there's 12 months in a year, and then you map over each of those spots, and you take the index of the array and turn that, and you create a new date, and you don't care about any of the other parts of the date. You just care about the month. So you set the month of the date to be the index, and then you can use this pretty handy little .toLocal string method. It's on dates. It's also on number and intl, which will allow you to format things that are internationalized. So currency and dates are probably the two biggest ones. And that's cool because you can pass it an actual code, or I think if you pass undefined, it will detect it from the user's browser. So you could automatically just inherit that from the user's settings, and then it will just give you the month names or the weekday names from the user's settings. It's kind of cool. There's a bunch of different settings that you have there. You can, depending on if you want to display it in long or in short. Next up is uniquify. This one's a pretty simple little tip. You have an array, bunch of items inside of it. If you put that array into a set is a new sort of array-like thing in JavaScript. If you pass it, it will just automatically remove duplicates. This does not work for objects and nested arrays, just for strings and numbers and booleans and things like that. But what's cool is you can just turn it around again and put it back into an array, and that's just a really cheap, quick way using array from, or you can use the spread operator. I'll talk about that in just a second. So that's now. Spread and rest, those three little dots, you probably see a lot. They either mean that they are a spread or a rest. So here are some use cases for spread and rest. First, if you need to copy an object, you don't need to use object.assign. You can just create a new object literal with curly brackets and then spread it like butter into the new object, and that will take every property from the array and put it into the new. That doesn't do a deep copy, that just does top level. So if you have a nested object, that will still be a reference. You can also, this is something I use a lot, where if I'm like on the server side and I need to duplicate an entry in the database, there's one thing that you don't need to duplicate, and that's generally the ID of the element. So you can either like overwrite that, so spread the entire thing. That will include the ID, but if you have a property twice in an object, it'll simply just overwrite the earlier one, and you don't have to worry about like database errors or something like that. Another thing I often do is, if you're sending this data to the database, it usually brings back the record with an ID. You don't give it the ID, it gives you the ID, right? So what you can use is, in this case, this is not a spread, this is called a rest, where you destructure the ID, and that gets thrown out. I know there's an ESLint rule, I'll probably yell at you there, you can turn it off. And second, this will sort of collect the rest, right? So we want to destructure the ID, and then the rest goes into an object called without ID, and that will give you all the property values minus the actual ID that you destructured earlier. This works really well with arrays as well. So I've got two arrays here, names and cousins. These are two arrays, and we do this all the time. We need to merge them or uniquify them or something like that. So very easy way to copy an array is to simply just create a new array literal, spread that existing array into the new array, and then you have a new copy of that array, and you don't have to worry about mutating the original array. If you want to merge multiple arrays, you simply just spread both of those into the new array. If you want to remove an item from an array, this is pretty popular in React and Redux world, where if you have an item you want to take out of an array, you can't just pull it out because that'll mutate the original array. So you create a new array, and you take everything before the item you want to remove and everything after the item you want to remove, and then the item that you want to remove is just left out of the new array. And then finally, this is something I use as well quite a bit. If you want to reverse an array, unlike like map, filter, all that, reverse doesn't return a new array. It actually mutates the existing array, which can lead to some like weird issues. So if you take a quick copy of that array and then run the reverse on it, you leave the original one as it was. What are we doing for time here? We're doing pretty good. Async flow control. So how many of you use promises and async await? Everybody, good. That's good, I'm happy to see that. So promises, if you don't know what promises are, they're sort of like an IOU for something that's going to happen in the future. A promise will either resolve, it worked, or it will reject, something went wrong. And here's the sort of the two ways you can use promises. You can get users as a function, and that will return a promise where it won't immediately give you the users, but it gives you a promise that it's going to do its best to go off and get the users. And then you can chain a .then onto the end, which will give you the users, or you can use an async function where you await that promise and then actually access the users inside of it. So let's look at some patterns around handling different types of requests inside of promises. So probably the one you might have used is promise.all. And this will take an array of promises. If you have multiple requests going out, you have multiple functions that return a promise, and you want to wait for all of them to resolve, then you can just pass them to promise.all. In this case, I'm calling get users and get products. And then once both of those have come back, I'll be able to go ahead and display them, or I wrote products, that's not the method name, display the products and pass it the actual products variable there. They run concurrently, which means that like one little like foot gun that we have with async await is that if you have like await get users and then await get products, you're actually waiting for the users to come back before you even fire the initial request for the products, and that's unnecessarily slow because you're waterfalling it there where they should both be fired off at the exact same time. And this ensures that they're run concurrently and waits for both of them to come back. I'm just using a quick destructuring there in order to put them into their own variables, because promise all will return you an array of resolved values, and you want to take them out based on the order that you pass them in. We also have promise.race. Oh, wait, I should say one quick thing about promise.all is that if one of your promises in promise.all fails, it rejects, then the whole thing is over, right? It's not going to wait until they're all done. It just says, screw it. one's broken, we're done. Let's go to the catch, or let's handle the error because something went wrong in one of them. Promise.race is whenever the first one resolves or rejects. So here I have a quick little function called wait, takes in an amount of milliseconds, and returns a promise. And that promise will resolve itself after however many milliseconds you asked. And it will also just return the amount that you waited for. Pretty simple little example of a promise. So if you want to know which one is the fastest or which one comes back first, you use promise.race, and it will resolve to you the value of the one that finished first. Whereas promise.all will wait for both of them to successfully finish. Now, we've got two new ones coming down the pipe. This one might not make it, but it probably will. I'd be willing to bet it will. It's currently in stage 1, which is the first stage of coming to the language. And promise.any is when one resolves or all reject. So that's different from promise.all, because promise.all, remember how I said, is if one of those promises fails, then promise.all is done for the day. Promise.any is a little bit different in that it waits for the first one to resolve. So if 3 or 4 of them fail, it's going to still wait out and be like, I'm still waiting. Probably one will come, and we'll wait for that specific one. So these aren't things you're going to use absolutely every single day, but I certainly have found myself in many situations that needed something like this, and it doesn't totally exist just yet. So in this case, promise.any, I'm waiting for 50 milliseconds and waiting for 200 milliseconds, and that will resolve to me 50, because the 51 is obviously faster than the first one. Next one is promise.all settled. This one's looking really good. It probably will make it into JavaScript. And this is waiting for everything to be done regardless of whether it resolved or rejected. So I think of this one as like the janitor that sweeps up at a marathon, where I just made this up. I don't know if this is dumb or not, but people go across the finish line at a marathon, and maybe some people take really long. Maybe somebody hops in a cab and drives across the finish line. Regardless of what happens, whether the promise successfully finished or it rejected, promise.all settled will wait for absolutely all of them to finish before moving forward or before resolving itself. Where would this be helpful? If you are trying to ping APIs where you don't necessarily know if that page exists. So in my case, I've got a bunch of usernames where I want to check if these usernames have been taken on a specific platform. So I'll make an array of user guesses, and then I'll map over all of those guesses and return a promise that will ping out a fetch request to all of those URLs. And that fetch request is either going to resolve, it came back, or it's going to reject. There's a 404 on that page, and the whole thing rejected. So what this will do is it will wait for all of them, and you get an array of results, and you can go ahead and filter those results based on whether they're rejected or resolved, and you can do anything you want with your data at that point. Error handling, a few options. Sort of the one downside to async await is that a lot of people just stopped handling their errors because it doesn't look cool. Because like async await is so clean and everything. So here are a few options for using error handling in async await. So first option is just don't write terrible code that you have. So don't spend time on something that will never happen. We've all been there. That should never happen. And then you get a call on a Sunday morning about the entire server crashing. The second option is try catch. So this is probably what all of us have learned when we looked at async await. So you basically open up a try to do your code, and then if anything goes wrong inside of that try, it's fine. You got a safety net around it. The catch will catch that error. You can go ahead and go off and handle it. That's good because it's just very simple, but it kind of ruins the nice top level. It's also a block, and if you're using let and const, they're block scoped, so that's a bit of a bummer too. So that's okay. Third is a higher order function, which is a very cool thing to say. It makes you sound very smart. It's an async, because async function. Does anyone know what does an async function return? Yeah, a promise. And if you have async function blah 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 and run it, it will return a promise, right? You don't have to explicitly return a promise; it just returns a promise to you. So that means that you can tag a .catch onto the end of asynchronous functions. So the way you do this is you just go ahead and live your life without any error handling. So I have a function called YOLO here, and I go ahead and await, and I assume everything is going to work fine. Then what you do, this is going to get a little hairy for a second, so hold on to your pants. You create a high order function that is a function that takes in a function and then returns that same function, but with a .catch tagged on to the end of it. And that's really cool because then you can do something like this. Oh, this is how you do it if you're a hot shot. There's probably somebody in the crowd be like, Wes, you could do that with 7 arrow functions, and it would have been much more concise and performant. But this is how we generally would do it. I wouldn't want to have to debug that one. But this is how it works, is that you take your YOLO function, which is you just living your life, and then you wrap it in that handle error. And what that will do is it will take your function and go like, okay, you dangerous little function, let me wrap an error handler around you. And then that returns a new function, which is called safe YOLO. And then that's the function that you actually go ahead and use in the code that you're running day to day. This is very handy. I specifically use this in all of my Express applications. How many of you write Express applications? Okay, of course in serverless functions, right? Okay, good. So here's an example of an Express like controller or route or something like this, where you have a function called get orders. That's an async. You get in the request from the server, you have the response, and then you have this next function where next what next is used is to pass it down to the next route because you didn't actually want to do anything inside of this route handler that we have here. And what we can do here is traditionally what we would do is we would just call like next if there was an error and just say like, oh, no orders found, and then just pass it down the line. But in our case here, we can just throw regular errors or create your own custom errors and throw them. And then what we do is we create a new high order function that takes in the error, the request, the response, and the next. And this is generally what you put at the end of your application. Sorry, this is not the high order function. This is what you put at the end of your application, where it generally is like, if you got this far, it's probably a 404 because no routes actually matched or something specifically went wrong. It's a 500 error. So that's okay, but it doesn't really cover errors that we throw, unhandled errors, errors in libraries that we didn't expect to have there. So what we can do is catch all the errors and pass them along to that middleware function. So we create a catch errors high order function here, takes in the get orders function that we just talked about. And simply all we do is take that function and tag a .catch onto it, which passes whatever error happens onto the next handler. And then what's cool about that is that instead of just passing get orders to the route, you wrap it in a catch errors, and then you just have this like one handy little function that will say like, if anything happens inside of here, just pass it to the error page, and then we can deal with it accordingly inside of the error page. Show something to the user. If you're in development mode, you can show a stack trace, something like that. You go ahead and, the next option that we have here is handling the error when you call it. So this is what I do in most of my use cases. So you have a function, you go ahead and live your life inside of that, and then when you run that function, you can tag a .catch onto the end. And that's really cool because, again, synchronous functions return promises, so you can tag a catch on the end and deal with it. Final option here is the unhandled, Node's unhandled rejection event. So Node has been saying for like 4 years that it's going to exit the process when a promise breaks. And if you want to stop that, because one day they will exit the process and your website will stop working, you can catch those unhandled rejections, or and go ahead and do something with it. So that's, what have we got here? How much time do I have? Perfect. Okay, so I wanted to talk just for a couple of quick minutes just about some future stuff. This is stuff that is not in the browser just yet, but it's being worked on. It's some ideas that are being passed around, and people are working on the future. So first one is the web speech detection. So I'm going to open up my demos here. And that's cool. Open this sucker up. All right, so what I have running here is a web speech where it's streaming in audio from my microphone, and it's automatically transcribing that to text. And you can do anything you want with that text. And in this case, I built a little app where you can say things like red, tan. Oh, that's a bad one. Green, gray, bisque, slate blue, Rebecca purple, medium aquamarine, light goldenrod yellow, hot pink, dark blue, olive drab, Gainsborough, Burleywood, light cyan. Oh, I'm goofing them up. What's like the hardest one you can see? Papaya whip. Killed it. So let's look at the code real quick behind that. So it's this new speech recognition API, and there's a couple options in there. You can get continuous. You can get interim results, which means that like it will give you the value as it's streaming in, which is why when I go to my example and I say something like medium spring green, you see spring green and medium spring green popped up. That's because I was doing continuous. As it was being fed in hot off the microphone, I was already analyzing it. And then you go ahead and start it. But we have this handle result function, and that's right here. So what do? You go ahead and grab all of the words said. In our case, I'm just grabbing the last word said. I went just lowercased it. I replaced spaces. So if I say something like medium spring green, I wonder if it's even streaming it into my console here. Yeah, these are speech recognition. What was it saying there? Can we modify the console log result of, whoa. Hello. Hello, Jamstack. How are you doing today? I hope you're all doing super well. My name is Wes Bos. Wes Bos, come on. Boss. So it's pretty cool because like it's obviously streaming it in as I'm talking here, and it gives you a confidence score. It also gives you multiple versions of it. You could see that I'm just logging the first item out of the array. So it's a very simple example. And then once you have the words, you can do whatever it is that you want with them. In my case, I made a little game where I could say things like slate blue, and sea green, dark cyan, and you get the point, right? It's pretty cool. I can't believe that it's like just like a couple lines of code to be able to stream that stuff in. There's also an API that does the opposite, where it takes text and makes it into speech. And specifically on the Mac, it's really cool because there's lots of voices built into the Mac, and you can change the pitch, and you can say, "Hi, my name is Wes Bos," and it's pretty funny. So the other thing I wanted to show you is shape detection. So shape detection is you want to be able to use machine learning to detect something in the browser. And currently there is, what is there currently? I have it on my slides here. There's face detection, which actually works surprisingly well. There's barcode detection for, I think, 3 or 4 different types of barcodes. And then there's text detection, which I was thinking like, you know how like the cops have like a camera on the front of their car and they like automatically scan your license plate? Like you could like code a web app to do that, which I think would be pretty cool. Don't do that. It's probably illegal or something like that. But those are the 3 types of shape detection. So I did the barcode. I've done the face detection a couple times, but I had never done the barcode one. So I just printed off some QR codes, and these are just QR codes that have colors inside of them. And then when the QR code is up there, then it... So you could imagine how handy it would be. And I know that some web apps already do this, but you could just I don't know, scan in some sort of barcode right off the web without having to have any API. I did there, it mixed them. So that's what I did. Let me show you the code for that. It's really cool. Barcode reader, here we go. So here what I'm doing is on initialization, I go ahead and get the webcam. I only ask for video in this case. And then I have a video tag on the page, and I go ahead and play it. That's how I'm getting my face, right? Then you create a new barcode detector, which is right here, new barcode detector. That's just built into the browser. It's currently only in Chrome, but they're working on a standard for the shape detection API. So this might change, but they're kind of play around with how it works. You pass it your video, and it returns a promise, so you can await it. And then you get an array of hits, and that will give you an array of all the barcodes that it finds, specifically in the... Hey, it still works. And then you can, I'm just saying, if the hit's length is 1, then change the background color to be the color of the QR code, and I just have the word green encoded into this QR code. And then in my case here, I'm saying if there's 2 of them, then take those 2 codes and mix them, and then I went on Stack Overflow and found some how to mix colors function and did them. So again, 39 lines of code without the Stack Overflow mixer, and it's pretty simple to be able to do that. And the code for doing face detection and text detection, so you could show it like a book and it could read the text out of the image, is very similar to how this works. It's the same, just detect it off of a video or an image, and then it will return you a bunch of different hits that you have. So that's some pretty cool stuff in the browser. It's still going. Hopefully you enjoyed that. I would love to chit-chat about anything else. JavaScript, I'll be around for a while. I've got a whole bunch of stickers if anybody wants one. And that's it. Thanks so much.